Section 11-5, like I said, is called angle relationships in circles. And so we're going to be drawing some circles and some lines, which creates angles. And depending on where the vertex ends up on your circles is going to depend on how you deal with it. So the first option is going to be when the vertex is on the circle. The second option is when the vertex is going to be in the circle. And the third option is going to be when the vertex is outside the circle. So when your vertex is on the circle, it's very much going to look like the inscribed angle that we did on Friday, right? So on Friday, most of you were getting it and doing good. And basically, whatever the arc is, you take half of that measure of the arc, and that gives you the measure of the angle. Okay, so we're going to see those again today. Those should be some easy ones, right? Then you're going to have some angles that are created with the vertex in the middle or inside of your circle. First, you're going to take the two arcs that are connected to it. You're going to add them together, and then you're going to take half. Okay? The third relationship in the circles is going to be when the vertex ends up outside. And for this one, you're going to take the two arcs and you're going to subtract them and then take half. Okay? This one's a little unique in that you want to make sure that you end up with a positive angle. So you want to take the larger arc minus the smaller arc. Okay? Then divide by 2. So you don't end up in the negative. All right? So looking at it real simply, if you have a circle, its vertex of an angle on the circle, creating an arc here of 120 degrees, you simply divide that by 2 or multiply by 0.5, multiply by 1/2. That's going to get you 60 degrees. Okay? Same thing is true going the other direction. So if you have an angle with its vertex on the circle, if they give you the measure of the angle and you want the measure of the arc, you simply multiply by 2. So if this angle right here is 100 degrees, then the arc is going to be 200 degrees. Okay? Those we saw on Friday, those you guys all seem to get pretty good. Well, you'll see some more of them today. Okay? The next kind will be a circle. And you'll have two intersecting lines creating a vertex in the inside of the circle. Okay? If we want this angle right here, we'll call it angle 1. And we have two arcs that are associated with it. So this one over here, we'll say it's 44 degrees. And this arc over here, we'll say it's 86 degrees. Those two arcs are associated with this angle 1 right here. So we're going to add them together and then multiply by 1/2 or divide by 2. Okay, so we're going to take 44 plus 86. Punch it in the calculator. I got 130. Then I'm going to divide by 2 because I think that's the easiest way, but however you want to do it, you can do it. And I got 65 degrees. Okay. The third relationship is when the vertex ends up outside of the circle. So if you have a circle and you have two lines coming off like this, and it creates this angle out here. This angle, to get it, you're going to take the two arcs and subtract them and then divide by 2. So this one right here is 45, and this arc right here is 125. You kind of have two options, right? Should I go 45 minus 125? No, that's going to get you a negative number. So make sure you take the larger arc, minus the smaller arc. I got 80. Divide that by 2, and you should get 40 degrees. All right, example number 1. And of course, we're going to start by drawing a what?
Circle.
Circle. Okay. Start by drawing a circle. We're going to have an angle over here. This intersection point is E. This intersection point is F. This intersection point is H. And this arc right here is 130 degrees. So I want you to find the measure of angle EFH. So you want to look at your 3 options up above and decide, is your vertex on, in, or outside that circle? Which is it? On. Okay? So next to on, it tells you you're just going to take half of the intercepted arc, which in this case is 30. So we're going to say the measure of angle EFH is equal to half of arc EH. And its measure is 130 degrees. And with my calculator, I got 65 degrees. Any questions on example number 1 there? Pretty straightforward, and it's pretty much like what we saw on Friday. Okay? Example number 2. Start with another circle. This intersection is going to be A. This intersection is B. This intersection is C. This one's D. And we'll make this point E. Okay. So arc AB up top here is 139 degrees. And arc DC down here is 113 degrees. I actually want you to find the measure of angle BEC. Now pay attention to which angle they're asking you for, right? BEC, if you tap it out, BEC is this one right here. Okay? But this one right here is associated with this arc and this arc. So this one's a little bit tricky. We actually need to find this angle here first and then get this one second. Okay? So if we get this angle first, then we notice that this makes a what? A straight line. A straight line. And so a straight line is going to be how many degrees? 180. So if we get this one first, then we just subtract it from 180 and we'll be able to get the second one. Okay? But let's do this one first. So we'll say that first we need to decide, is it on, in, or out? Obviously it's in, okay? It's in, so we're going to add them together and then take 1/2. So we take the 139 plus the 113. I got 252. By adding them together, divide that number by 2, and it's 126. Okay, so this angle right here is 126. So now we actually need to get the measure of angle BEC. So we're going to take 180 minus the 126. Punch it in the calculator. I got 54 degrees. Okay? Any questions on example number 2 there? All right, I'm going to move it up. You'll see it in just a second. There it is. Where's example 3? There it is. Example number 3, here's our circle. We're going to put a point over here. 2 lines come in. We'll call this intersection right here, oop, A, this intersection B, this point C, intersection D, intersection E. So A, B, C, D, E. All right, and the measurements, arc AE is going to be 200. Arc BD is going to be 74. I want you to find the measure of angle ACD. So if you tap out ACD, here's A, here's C, here's D. That's this angle right here. So put an X there, a question mark, or a little arc mark, whatever it takes. And then look at your three choices. Is the vertex on, in, or out? Out. So if it's out, then you want to subtract and then take 1/2. Okay? Only thing tricky on this one is that you do the larger minus the smaller. Okay? Other than that, it's pretty easy. So 200 minus the 74. I got 126. We're going to divide that by 2. I got 63 degrees.